Hello, hello everyone. This is Sri Krishna Bhatt. I will go over Informatica Connector Toolkit, the overview, and demo of developing any connector using ICT. So agenda will be, and once this session is done, you will be able to understand the adapter concept and the building process and a connector development flow. I will be demonstrating developing connector of a connector, Redis connector, that is a key value database kind of connector system. So at end, I will touch upon the connector versus consumers, that like how connector looks in different products what we have, like Mercury, Cloud, and PC. So to start off with the SDK concept, if you start like why we started SDK and what's the app SDK's role here is like develop a connector and deploy anywhere. This is a concept we started writing and run anywhere. So currently with our product like Cloud, PC, and Mercury, the whatever connector developed using ICT is supposed to work. When it comes to an architecture, the SDK layer comes in between the different consumers and the third-party system. So ICT play a role of developing a connector using this SDK as a backend and provide an interface to the third-party system and our product. So simple architecture. So there will be an CCI, that's a common consumer interface, will be sitting on each consumer to provide an abstraction. There will be an abstraction layer between SDK and different tools. So when it comes to an Informatica Connector Toolkit, there will be a couple of aspects we need to consider: the patterns, what view the third-party system is there, and the extensibility models, and the UI, how it will be rendered, and the type system, and a couple of adapter connector components. In the patterns, we can think of flat, midstream, hierarchical, real-time, and graph. So currently in ICT we support, in SDK we support flat and of hierarchical bit, midstream as well. So when it comes to a flat, we can think of regular relational kind of systems and flat file kind of systems. Midstream is not something like it's a call or a procedure or a BAPI in SAP, BAPI call in SAP, and something similar to that. It will be in between a source and target. And hierarchical is something like XML, JSON kind of system. Model extensions. Currently, we need for record, field, and runtime level. So the extensions is nothing but for record extension, it's nothing but properties or attributes related to a record. For example, in Oracle, the record will be like a table. It can have a properties something like table name, the owner, when it got created, who updated last, etc. Same way, field will have its own properties like field name, type, precision, scale, description, is nullable, the owner, writable, readable, etc. so on. So these all are the extensions we need to identify while developing in a connector. Runtime is in the same way, like it requires the properties required to communicate with our party system for reading or writing purpose. And the UI, we have multiple different products, right? So Mercury will have an Eclipse-based UI, and Cloud will have UI web-based, and PC have a C++ kind of Windows client. So how do develop an UI for my connectors on different platforms? So ICT will take care of this. ICT will be, if you write a code in Java and prepare your objects, and in ICT you mention where it's supposed to go, which page it should go, which section is supposed to go. You design your interface, and that will be rendered and showed in the different products. Type system is like a third-party system. How you map third-party system type system into an Informatica platform type. Sorry. So Informatica platform will have some set number of data types, but third-party system may have more data types. So you need to map to, and so there is a two-way. Either you can map it to a platform-supported type, or you can go with the Java type system. So if you are comfortable with the Java type system, then map your third-party system types into a Java type system, and internally we take care of converting it into platform type. So these things can be covered in ICT Demo as well. I will explain there as well. When it comes to an adapter components, so type system, connection, metadata, runtime, at end we will need to take care of licensing as well. So I'll skip this. Yeah. Prepare to develop an adapter, we require to identify before developing any adapter, we need to understand the third-party system. What kind of system and what and all properties required to connect to that, the type system of the system, and the metadata NMO, like what kind of records we are targeting to read or write. Then attend even the runtime APIs, whatever the third party is exposed, you need to understand how to consume that. Informatica specific things, you don't need to worry that ICT or SDK will take care. So the development effort is only from the third party specific things. So as it is generic, it's not generic. The process will be simple. You develop connector, then you update your implementation, then build it, test it within ICT. If there is any bug, then again modify your code and build it, test. You continue this process until it works, and then you publish. It will be ready to consume from different consumers. So by this, I will switch over to demo. As I said, I will be demonstrating developing a connector for a Redis system. So you need to install ICT and Redis as well. So I have a document, the lab. It is initially designed for a 6 to 7 days workshop kind of thing. So I will quickly go over this while doing demonstration. I will use this as a template. So for Redis, you need to install Redis server on your system and the client to access that. That can be downloaded and installed. I will skip those things. So Redis requires mainly the username, password, host name, and the port where it is running to connect to a system. When it comes to a type system, it supports string, list, set, sorted set, hash. These all are the types they support. As I mentioned, it's a key value database. So our record will be in a key and field will be in a value. There will be one single value, single field as a value. With that, I will switch to ICT. You need to install ICT. ICT can be downloaded from a marketplace, Informatica marketplace, or contact our GCS. To install ICT, you require Eclipse to be there. Please refer user doc for respective Eclipse version, depending on your ICT version. So once you install, we are ready to go. So I have installed ICT already with this Eclipse, and I will switch over to the perspective. So Informatica connector perspective. First time it will ask set target platform, click on yes. So this is a page for any development. So to develop any connector, you no need to go anywhere. That one page is enough to test and develop. So there is a toolbar. You can see a create connection button. Click on that. Then you can start. So this is the first step, creating a connector project. For now, I'm developing in a connector for Redis system, and I'm specifying same as a connector name and ID. I'll give Informatica as vendor ID and name, and the description you can mention. So everything is captured in doc. I will even share this along with this recording. This description will appear on different consumers where it is deployed, wherever it is installed. So this is once project is done, you need to follow the steps, whatever mentioned in project completeness path, connector progress path. So first step is create connection. I'm creating a connection of type Redis, and it is categorized under the database. So this is just for categorization purpose, nothing to do with functionality. Currently, this categorization will impact only for Mercury UI. It's not considered for cloud and PC. So here we need to define connection attributes. As I mentioned, for Redis, we need a host name. Host name is of type string, and default value can be specified. Now I will skip. Minimum and maximum length can user provide, and is it encrypted? No. Is it mandatory? Yes. Remaining and all I will read to the default. The second attribute I expect is a port number, that is integer of type, and there is a default. So I will just mention the default one for my, it is 6379. So I'll just mention that instead of specifying every time, and it's mandatory as. So to connect to an registry, we require host name, port. Other than this, you need a password. So password can be an optional. You can configure a password for the system or not. So for my system, I haven't configured for demo purpose. So I will add one property called require pass. This is to tell that is my system requires password or not. It's an of type boolean. I just make it as false for by default, and that as dependent. So what is meant by dependent field? So it means if a user changes value for this particular attribute, the adapter code gets called. Adapter, a specific API, I will go over this API, will get called to do an operation. What to do? In this scenario, if I specify require password, then enable my password field. Let's go. I'm going to add now. Password field of encrypted. So if require pass is enabled, then password field makes sense. Else it is not. To handle this kind of scenario, we can define it as a hash dependent. So with that, this is the UI rendering. So I will categorize this under one section in the first page. There is no multiple page. We can add and we can configure this as well. But for demo, I will go with a single page and single section. Under that, I will list out all the properties. Last step in create connection is a third-party system. To connect to a system, mainly for Redis, I need a JDIS 2.4.2 jar to be in place. I'll just add that and I'll do a generate code. So by the time I will go into the Redis bit, so this is a Redis. By default, there will be 16 DBs get created. For every DB, you can have keys, multiple keys. You can define your own key as well. Define new key of type which. So here it says list type is a team of type list, and it has value called India, Pakistan, England. So here field is only one, that is called value, and the value of the value field is India, Pakistan, England here. So here code generation is done for connection. So once code generation is done, you will see two Java files. Internally, we create multiple Java projects. Just for reference, I will switch to Java perspective and show you. So there are multiple projects gets created as and when we progress. But to an adapter developer, they need to worry about only these two Java files are required. What is there? We'll go through that. In connection, the developer needs to worry about only two classes, two APIs, open connection and close connection. Open connection is to connect to a third-party system and give the status. Are you able to connect it or not? Close will to close your connection object. So I have predefined code already mentioned for demo purpose. I will import my JDIS class. Then I define a private variable to create a JDIS connection object. Then in open connection, I will create a connection code. So here what I am doing, I am creating a JDIS object by using hostname and port. If required password is checked, that means user is supposed to enter password field. Then I am getting the password and setting it as authentication. Then at end I will connect to the party system. That's some open connection. Then I close connection. I just disconnect JDIS object. Instead of returning this, I will return JDIS. And there is one new method required to return. Custom method can be added here. So this will be used in some other places. So that's a connection implementation. I'm done here. So if you look into other Java files, there are two APIs. One is validate attributes. This is to validate your connection attribute, the boundary condition or any adapter specific validation. If you wanted to put in for any attributes, you can do it here. You will be getting attribute values as and when user enters in UI. You can validate here and send the result. Another API is the updated consumer input. This is what I was talking about, the dependent field. So in this example, if user enables or disables or checks or unchecks the has required password field, then the call gets here, this particular API. Here you can manage that password field needs to be shown or not, or enabled or disabled, that you can do. So you can refer a sample program, sample implementation for this in sample connector what we provide along with ICT. In ICT you can see cloud, MySQL Cloud, YouTube and Instagram as a sample connectors. With that you can see how to implement these methods. So with that connection part is done, we can do a test connection here. So I will go into test connection. This is local host and I don't have password. I'll do a test connection. In test connection, there will be two steps. One, we build a connector internally. We package like a normal connector package for a consumer. Then we do a test connection on that. So that those two processes will do. As it is first time, it takes time to build an adapter. Meanwhile, I'll go into doc. The same thing is mentioned in doc, connecting third-party system, connection, test connection, and once it is done, we will move into type system. We are still in building adapter. Now we are doing test connection and it is successful. I'm able to connect to the third-party system. So that kind of connection. Then next step will be in a type system, defining type system. There is a two way. You can define manually or you can predefine type system. Use predefined type system. That is nothing but if your system supports only the Java type system, Java specific type system, then you can go with the second option. For now in Redis, it's not Java specific. It has its own type system, so I manually add it. So what all are the type system we have? We have a string and a set and a list. I will add one by one. String is my native type system, and I will map it to a platform string type system. It has character units and there is no restriction, and it's best mapped to a string. Next I will add a set, that is also again a string data type. And I have list, that's again string. I will map it these three as string. Then we have int and time. Time I will map it to date. Int I will map it to integer. You can go over this best map how when there is multiple type system mapped to a single type system, then we can look how best map from native and platform will work. So by this type system is done, I will do a code generation for type system. Next step would be creating a native metadata object. So in Redis, my native metadata object is key, and it's of type record. Procedures are mainly for midstream or hierarchical kind of patterns. You can go with procedure. It's a record type, and I'm not going to add any of the record extension and field extensions for this. My connector supports read capability, and I have an read capability attribute called getQuery. This is not a mandatory kind of attribute. It is a kind of pre-SQL or SQL with respect to Redis. In a relational world, whatever pre-SQL or SQL we can give, right? Same way we can give it here for Redis. It has its own syntax, so that needs to be followed. And I'm not going to touch upon lookup and the different operations we support. And write capability, my connector supports write as well, so I have a write capability attribute called setQuery. This is to, again, DDL kind of queries you can specify here. And it's this page we mainly configure partitioning. Currently I'm not doing this, and we can skip this for this demo. So with that, NMO creation is ready. Now the implementation is pending. Again, for implementation, I need to import something. Yeah, code generation is done, and building also done, workspace building also done. If you open metadata, there is one more Java file got added. that needs to be implemented. What and all is there? Let's go over here. Here only the populate object catalog and our populate object details. These two APIs needs to be implemented. Populate object catalog will be a first call whenever you do any metadata browse. Here the developer needs to generate the catalog, the pattern catalog from third-party system. And in details, the fields and the properties of each record will be populated. So as I have code set ready, I just import. Three APIs and I define two class variables. Then the code implementation. This is for catalog. There will be sample code generated for your reference. You can skip, you can delete here for demo, or you can refer that. So this is object catalog, then I will implement. So let me go over what we are doing here. So while doing a browse, we get the connection. This is the connection what we created in connection. Then while browsing first time, you will be having start folder as null. This is nothing but the parent. There is no parent. You are starting to browse. So first step, I'm connecting to Redis and I'm getting all DBs, DB0 to 16 here. Next step, whenever user selects DB0 or DB1, here if you see, right, the first step we are defining, we are constructing this. Whenever user select any of this DB, we need to construct key values. That is what we are doing here. NMO key getting, and we are adding it as a child record. Once user selects any key, then we need to construct the field attributes, fields, right? Again, there will be sample code. I will delete that. I will replace with my predefined code. So this completes metadata connector implementation. So next step will be, again, you can do a test connection, test metadata here by going with the test key. But for demo, I will skip that. The same process like test connection. I will set up the runtime part. Runtime you can configure using Java or C. I'm going with Java for now, and runtime also requires JDIS jar library. This is already added at connection, so it is coming it as runtime. If you want anything else, you can add it here or you can change it. So I will generate runtime codes. That is what defined here. Once runtime code is ready, we need to implement multiple APIs at runtime. Mainly we need to worry about data adapters, Java here. This operation manager, other things are mainly required when it comes to a partitioning and other features what we support. As I'm not targeting here, I'm concentrating only on data adapter. Here we have set n number of APIs needs to be implemented. Mainly the init data session and the init, read and write. That's all. Remaining all are supported methods. No need to worry. It's all auto-generated. So again, I need a couple of private variables. Then import, I will take it at the end as there are multiple imports required. So I will do Shift-O, Control-Shift-O to get all the details. So I just add my Java code here, sample Java code. And then read, I'm adding reader part. and I have write implementation. I will go over what we are doing here. No. And I will resolve all the compiler issue by pressing Ctrl Shift O, and there is a semantic phase operation that is required. So it closes all compiler error. So let's go over that read part, what we are doing. In read, we are maintaining a list of table record that to add all the records read from the party. Then I'm getting the same Redis connection, whatever we defined at runtime, connection type. Then we are getting runtime configuration method handle that will contain all the metadata of your mapping object, mainly the source or source object, whatever Redis object. And the runtime capability attribute, I'm getting the get query attribute, and I'm using that, solving that here in read data from source. And I'm parsing the query, whatever the user provides, and depends on that, I issue a command to the third-party system. On write, same way, I'm just preparing same, and I'm writing into third-party. Also, I'm taking care of runtime capability attributes. It's pretty simple implementation. So, with that, I will just go with the testing the runtime part. Test read. I'm connecting to third-party system now. So I will try to get the details of the teams list here, India, Pakistan, England. If you see here the machine arguments, right? These all are debugging options. Once you are in this test wizard, you can debug using remote debugging option in Eclipse by connecting to port number 8000, or you can configure that before pressing next. So now the JVM will be launched with this 8000 address, and you can connect from your Eclipse, and you can do a debugging of whatever you implemented now. Now it is building complete adapter, as we have runtime implementation is also ready. So it is something like the release kind of packaging it is internally doing to do a test read. So now we connect to the system. It's the same my local host port. So it lists out all DBs, whatever we have. I will go over DB1 and I'll select teams. Teams have field type of value is their field. Click on next. I'm not providing any get query for now. I will run. So it's supposed to now get me the value of teams key. Teams key value will be like India, Pakistan, and England. So we're getting India, Pakistan, and England. This is the reader part. Let me go over same thing with the writer as well. Write test connection, how it is. So what we will do, I will add one more entry here, India, Pakistan, England, and I'll put some Sri Lanka here. And in write extension query, that is set query I will try to create one more new key. So I will connect to this. and I will write it to a Teams field and source. To write, I need to get it from source. So ICT provides the capability to load from file or you auto-generate. So I'm writing one record extra. So this is auto-generated. I will change it to Sri Lanka here now. So it will add that. And I set so I'm creating a new key called test write and with value sample data. This is a DDL kind of query I'm running along with the write. This is a syntax for Redis. So yeah, it successfully wrote one record. Let's go and validate it in my tool. I refresh this. Yeah, I have Sri Lanka got added. Also, I need to refresh here. Yeah, test write is here. So its value is sample data. So that ends the development process. Once as we have the connector is ready, then we can publish to Informatica Cloud or a Power Center, whatever the plugin ID. You get the plugin ID from Informatica by connecting to Informatica GCS. You can get this ID and finish. So that will generate. Where is my workspace? I'll go into my workspace Redis, and there is a deploy folder. There it will generate the artifacts. So the cloud, yeah, it is completing. So cloud, it will be a package also zip. You can upload this zip to your production pod. And for Mercury, it will be like installer, we are providing batch files. So by providing Informatica install location, you can install this. For PC also, we are providing batch files so that you can install it on PC. So these all are final connector installers or a package. So that ends the demo part. There are multiple areas to cover, mainly the messaging part. There is a message icon you can see here. So these all are the message properties file you can provide and you can localize later. This can be used whenever you are providing an error message or a fatal error message to an user. And lookup properties and operations like a space, select, sort, join and all. Partitioning options and reject record related queries you can cover. So these all are the aspects every connector will come across. So, but to start off, this particular demo should help you to kickstart the process. Then you can explore the different areas whatever ICT provides. Next, I will move on to the connector and consumers, as I mentioned in there, how these connectors look in our different tools. So I'm using a MySQL sample connector for this. So I have a screenshot, set of screenshots. Anyhow, I will pass on this as well. So this is how the test bed looks like, right? So when I do a test connection, this is how the test bed and the connection rendering part and all looks like. But when it comes to a PC, it will be of PC workflow manager. You will see the connection, then connection subtype, and here you will be seeing the properties whatever mentioned. When it comes into Mercury, it will be on Eclipse tool. So this is how it will show. And now the preference pages. In cloud, you go into log into your production pod and then go into configure and connection. There you can see select the type of your connector, whatever you uploaded. On metadata front, this is ICT. how you browse your metadata and the details. On PC, while importing, you will see similar kind of metadata, but only here advantage is that you can do a data preview as such while importing metadata to just validate for subset of records. So in Mercury, it will be on Object Explorer, while in a project, while creating, you can import metadata. In cloud DSS task, the similar data preview is the advantage you will get, and you can select records in that. Other operations like filter, join, sort, and all, like in ICT, we can configure this, and it will appear something like this in while doing test connection in ICT. On PC, while importing, you need to configure these properties like filter. Join is not supported. Now, Mercury, you will get all the options in data operation level. On cloud, you can configure filter in DSS in data filter tab. Similar way, we can do it in CMD as well. Join can be done in source tab. The extension attributes will be visible. Mercury, it is at operation and data NMO level. And the runtime properties will be at a data operation advanced property. In PC, everything will be visible at session level, like other connectors. On cloud DSS task, it will be on 6th schedule tab, and data. In CMD, it will be under source properties section. Partitioning currently is supported in PC as a pass-through partitioning. It's at the session level, and in Mercury, it is at the operation level. So these are some advanced properties like metadata write options. If you want to consume a create target kind of option, it will support in ICT as well. I didn't touch upon demo. So that ends my presentation overall. So if any questions, anything, if you have in your mind, please talk to GCS, or you can put it in marketplace section, ICT page. There people will regularly look into and address your issues. Thanks for your time. Have a nice day.